Hello everybody, today we'll be talking about angles. Now angles can be measured in degrees or they can be measured in radian. So when you have this little circle on top of a number, then the angle is in degree mode. If it's not, then it is in radian. You don't have to have a pi for it to be in radian. If you have an angle, like 3 for instance, since this does not have the circle on top of it, this must be in radian. Sometimes we call it rad for radian. Okay, so what is a radian? A radian is an angle that is formed whenever the arc of a circle, the arc length right here, is equal to the radius. So if this is equal to the radius, then this one right here is 1 radian. So radian is formed whenever the arc length is equal to the radius. Okay? Now, speaking of circles, I'm going to go over unit circle right after this video, so make sure you view that as well. All right, so what do we have? One full revolution of a circle. One full revolution of a circle is 360 degrees. 360 degrees in radian, that is 2 pi radian. Now, if you divide this by 2 on both sides, what are you going to have? 360 divided by 2, that's going to give us 180 degrees, and that's equal to pi radian. Now, you can use that as a way to convert from radian to degrees or degrees to radian. For example, you can use 180 over pi, 180 over pi, or pi over 180. Now, we use this whenever we want to convert to degrees. So to convert to degrees, we use this. And then we use pi over 180 degrees whenever we want to convert to radian. Okay, so let's have an example. So convert the following to radian. So let's see. Take for instance 60 degrees. Okay, so since I'm gonna convert it to a radian, I have to multiply by pi over 180. And as you can see here, the degrees would be canceled with the degrees here. Okay, and then obviously the 60 and 180 would also be canceled, so the 0 and the 0 would cancel. You have 6 pi over 18. I can rewrite 6 pi as 3 times 2 pi over, or I didn't have to because this is 6 times 3. So 6 times 3. So I didn't need to change this. But anyways, 3 times 2 is 6. This cancels with 6. And the answer is pi over 3 radian. So 60 degrees is pi over 3 radian. Now using another example, if you want to convert 150 degrees to radian, 150 degrees, again, I'm changing to radians, so I have to multiply by pi over 180 degrees. And then here the degree cancels. The 0 and the 0 cancel. Now if you notice, this is a multiple of 3, and so it's multiple of 3, so I can rewrite this as 3 times 5 times pi over 3 times 6. So the 3 cancels, and you'll be left with 5 pi over 6 radian. Now, let's use an example where we convert a radian to degrees. So let's have one example. So for instance, you have pi over 6. Now, to convert it to degrees, I'm going to need to multiply by 180 over pi. So pi over 6 times 180 over pi. So this way, what's left in the numerator is the degree, and this pi cancel. And you're left with 180 divided by 6. 180 divided by 6, you can, if you want to write it like this, and that will give us 30 degrees. So pi over 6 is 30 degrees. Now, also to convert between radian and degrees, you could use another formula. You could use this formula, theta over 180 equal theta radian over pi. So this one right here is an angle in degrees, and this is an angle in radian. So if you have an angle in degrees, you plug it in here, you find the angle in radian. And if you have the angle in radian, you plug it in here, you find the angle in degrees. Okay? So if I use an example that we just used here, 150 degrees, using this formula right here. So 150 degrees, that's in degrees, so I'm going to plug it in here. So what do we get? We get 150 divided by 180 equal to theta and radian over pi. You can simplify here the zeros, and this is again 3 times 5, this is 3 times 6, so they can cancel out. So you can, if you want to, take care of it here. 3 times 5, this is 3 times 6, theta radian over pi. The 3 cancel out. And then you want to get rid of the pi here, so you multiply this by pi, and you'll be left with theta in radian is, this cancels with this, by the way, so theta and radian would be 5 pi over 6. This is what we found it to be right here, 5 pi over 6. So you may want to choose this, or you may want to choose this to convert from degree to radian or radian to degree. There is, you can also think about it, you can also do it in a slightly different way. So if, for instance, if I show you here, you have here, we already established that 180 degrees is equal to pi. So to find out some of the angles, for instance, if you divide this by 2, you get 90 degrees equal to pi over 2 radian. So now what do we have? So here's our circle. This is 0. This is 90 degrees, or pi over 2. We just found this out. And then here is 180 degrees, or pi. Okay. And then you can use other example. For instance, I can find pi over 4 from here. So, or 45, which is going to give me pi over 4. So if you divide this by 2 or multiply by 1/2 on both sides, 90 divided by 2, that's going to give me 45 degrees. And that's going to give me here pi over 2 times 2, which is 4. So here, which is 45 degrees, and that is equivalent to pi over 4. I can do, you know, couple more, the common ones. For instance, I can do pi over, or I can find here the 30 degrees. What is a 30-degree angle? Again, if I use 180 degrees equal to the pi radian, how do I get the 30-degree angle? Well, if I multiply this by 1 over 6 or divide by 6, maybe you can divide by 6 here. So 180 divided by 6, that's going to give me 30 degrees. And that's going to be 1 pi over 6, or simply pi over 6 radian. So the 30 degrees, which is a third of that, the first quadrant, if I go ahead and graph it separately here, here's a 30 degrees, a third of the quadrant, and that is 30 degrees, which is pi over 6. Okay, and that's how we get this one. Now we have 45. If we want to choose 60, we already found it. It's pi over 3 over here. But also we can find 60 from this as well. If you divide 180 by 3, or multiply by 1/3, 180 divided by 3 gives me 60 degrees. And that is pi over 3 radian. So this is the 60 right here. And that is pi, 60 degrees, pi over 3 radian. And here is 45, pi over 4. Okay, so these are common angles that you would find in the first quadrant, or you can also find the common angles in all 4 quadrants, 120, 150, and so on. You can use this if you like. But whenever you're dealing with angles that are not so common, for instance, if you want to find the radian of an angle that's 18 degrees, it might be a good idea to use this. You plug in 18 here and you find the radian measure. Okay, so I hope you find this video helpful, and please stay tuned for the next video. Have a good day, everyone. Bye-bye.